crosslink PEEK, for those who may not be aware, PEEK is it's a great material, strong, chemically resistant, semi-crystalline thermoplastic. Greene Tweed was one of the first companies to really introduce PEEK in the 80s and 90s, and one of the largest users of it for many years. So we have a great pedigree there. But what we found several years ago was that the PEEK wasn't quite meeting the needs of some of our really demanding applications. So we developed the crosslink 3060XT platform, which provides several benefits over PEEK or other high-performance polymers. In a nutshell, you have PEEK and you mix it with a crosslinker, and which you see over here. And when you heat it, you get a crosslink material. So our patented crosslink technology is a very chemically robust crosslinker. So it's equally resistant to chemistries, hot, wet, high temperature solvents, etc. You get an increase in glass transition temperature, an increase in use temperature. Also, when you go through your TG, your glass transition temperature, where you tend to soften, you'll have a higher maintenance of properties. And I'll show some of the details in later slides. But in general, these are the advantages you get with a crosslink system. Also, for chemistry, you get reduced swelling in solvents, reduced diffusion of ions, so you have less permeation, and also lower DC, higher DC resistivity, lower conduction. So great electrical insulation, especially at higher temperatures where you might get a drop off in PEEK or other polymers. So it maintains all the features and benefits of standard PEEK, but addresses some of its major weaknesses in the space that we work in. Reduced swelling is especially critical for some of these applications where the chemistry is very aggressive. So chemical resistance, when we launched the material, it was for downhole applications. So we tested in aqueous and non-aqueous chemistries, acids, bases at high temperature, even Norsoc, which is a very demanding chemical test with high hydrogen sulfide gas. So Arlon 3000, the base resin, passed all these tests. We've got a Norsoc certificate for it as well. And we use that base material with a filler with glass to get higher structural rigidity. So we have a great chemical resistance of the base resin, and then an improved mechanical properties. And for electrolyzer and fuel cell applications specifically, we have tested in representative acidic and basic environments screening tests that show that it's the glass-filled version maintains a great chemical resistance.